Hello champion, I'm teacher Adam. Welcome to my math class. Today we are going to learn about surds. We will be simplifying surds. Simplifying surds. How do we simplify surds? Simplifying. So simplifying surds means you are breaking the surds from its big form to small form. So we say big to small. In other words, big to small. It's like the other ones, when you're talking about, like for instance, when we're saying that expand and factorize. To factorize, it means you are getting from big to small, and to expand, that means you're getting from small to big. When you have expressions like algebraic expression, let's say a plus b, and then outside the in the bracket, then there's 2. So to expand, that means you will multiply 2 times all element in the expression, maybe 2 times a plus 2 times b. So to simplify surds, in other words, you are getting it from its big form to small form. For example, and we know a surd. What is a surd? We say a surd is when you are finding square root of numbers that are not square. In other words, when you find the square root of these numbers, you will not be able to get a whole number or a rational number. So that's the definition. So we are going to, let's say we have square root, let's use the theorem, square root AB. So we know when you're finding the square root of AB, it can as well be written as square root A times, in the bracket, times B. The idea of simplifying these surds is normally found by first of all, when you're given a big number, you have to either look at the factor. Find a factor within the number. For example, let's say we have a number like 98. So ask yourself, in 98, which number is a square number and which number is not a square number? So from that, because in most cases, when you're told to simplify, they always want you to maybe to write your answer as maybe a root b. The b in the square root might be a number, any number that is not square. For example, maybe an odd number, and a will be the outcome of a square number. When you find the square root, maybe square root of 49 and get 7, and then root 3. So we say your answer is 7 root 3 in other cases. Now, for example, when we the law of surds, we said when you're finding square root of AB is the same as square root of A times square root of B, and this one can be broken as root A times root B. And then because one of the number either between A and B can be square. So for example, if this is a square, for example, maybe say A is A squared, obviously you'll be able to get a square number which will be a whole number. This will be a whole number, but this one will remain as, the second one will remain as root B. So for example, let's say you have a number, we have root 48. So our idea, we have root 48 and we need to simplify these surds. So to get root 48 without the use of calculator, what are we supposed to consider, champion? What you are supposed to think about, how can I break this into 2? So to get 48, I have 2 factors. 48 can be in table 3, or can be in table 8 or 6. So, but for I to be able to get a square number, obviously it will be between 16 and 3, which is 16 times 3, which is 48. And then this one can be broken as root 16 times root 3. This is a square, 16 is a square number. Therefore, I'll be able to get it as a whole number. Then root 3 is not solved. You've left your answer, and that's how you simplify. This is how we basically simplify surds. When simplifying multiple surds, simplify each separately. How? For example, this is another rule when you're simplifying surds. For example, we say root 32 plus root 8. Okay. When you're told to add, we know the only way we are able to add surds, is when these surds have common number in the square root. So the only way you can add surds together, you can say 3 root 2 plus 4 root 2. This one you can add and say, simply because they have the same square root with the same number, within the inside the square root symbol. Therefore, you only add coefficient, say 3 plus 4, and then you keep the number the same and say this is 7 root 2. This is correct. You're given 5 root 3 plus 7 root 5, and then say this one will be the same as 5 plus 7, then this one 3 plus 5. This is wrong because this one is not the same as that one. We understand that. The same with this one. So when you're given different numbers in the surds, like say root 32 plus root 8, solve each one of them separately. How do we do it? Now this is how we do. So we know we have root 32 and then plus root 8. Now break this into 2. We say the factor of 32 is 16 and 2. 1 is square. Find one that is a square number. So root 16 times root 2. Then after getting that, and we know also this one is the same as root 4 times 2. That's it. Then break this. It will be root 16 times root 2. This will be the same as 4 root 2. Solved here. Then the next step plus, remember this is root 4 times root 2. The same as this one will give you 2 root 2. So we have gotten this one as 4 root 2 and this one 2 root 2. Therefore, come here again. Say now we have 4 root 2 plus 2 root 2. Now, simply because we have the same, this is same. So we only add coefficient. This one are called coefficients. Coefficients, they are numbers before the surd form, the surd symbol. So we say 4 plus 2 and then keep the same. So you have 6 root 2. That becomes the answer. That's how you do. You may have to expand double bracket containing surds. How? For example, you have you've been given like maybe you have root 6. This is another way of simplifying surds. We have root 6 minus 2, and then we have root 6 plus 4. And then you're told to expand. What do you do? What do you do basically in this? So this one, it's easy. Just take this one times that, root 6 times root 6, and negative 2 times 4. So root 6 times everything there. Root 6 times 6, root 6 we know that's 6. Root 6 times that is plus 4 root 6, and then negative 2 times root 6 is negative 2 root 6, and then negative 2 times that is minus 8. And then expand. You say 6 plus 4 root 6 minus 2 root 6 is plus 2 root 6 minus 8. And then say 6 minus 8 plus 2 root 6. And what do you get? This one will give us 6 minus 8 is minus 2 plus 2 root 6. And obviously we always start with a positive number. Say 2 root 6 minus 2. That's the answer. You solve it as that way and you end up getting your answer. Now we're going to look for some certain examples. Example 1, say you have root 54 minus root 24. We say you cannot say this one, you cannot say 54 minus 24 and then find it. Some students will just go and say, 54 minus 24, then this is root 30, and then this is wrong. Don't do this. This is where the confusion starts. We say solve it separately. Find square numbers, a factor of 54. Which number within 54 you'll be able to get? So 54 falls within table 9. 9 times 6, break them into 2. Minus which one which one is a square number in 24? Table 4 and 6 separately. Then here solve each separately. Root 9 times root 6 minus root 4 times root 6. Solve them separately, individual. What happens? Say this is the same as 3. This one, root 9 is 3, but root 6 we cannot get. Minus root 4 is what? It is 2, but root 6 we cannot get. Then solve it. Now they have same number inside the square root symbol. Like you say, they have root 6 there. Therefore, you can now Subtract only the coefficients. So how do we do? You just say 3 minus 2, which is 1, and then keep the surd. So your answer here, how do you do? These are what called coefficients. This is what are called coefficients. Now we say 3 minus 2, then keep that, and your answer becomes 1 root 6, which can also be written as just root 6. It's 1, obviously. Right, nice one. This is how you simplify. So we can solve some questions that normally come in this unit that has been tested in your final IGCSE exam. I'll basically try to solve as many questions as possible. So say simplify. We're simplifying surds. Simplify. Simplify, they say root 32 plus root 98. Wow, this is so easy. In 32 and 98, if you don't know which number, just do this. 32 to use the prime factors. We know prime factors. Prime factors within 1 and 10. They are 2, 3, 5, 7. So always get a number, see which one is able to divide it. Like 2 there, it's a 16. So you see, 16 is a square number. So you got that. And then say root 16 times 2 plus 98. We know 98 divided by 2, 49. So 49 is a square number. So the idea, you should get a square number and an odd number. A square number and an odd number. A square number and an odd number that will not be able to get its square root symbol. So one should be, you say for example here, 2 times 49. So 2 is odd number, and then 49 is a square number. So you are able to find this square root, but this one you won't because you get decimal. That's it. So 49 times 2. Then break. Separate them individual. It will be root 16 times root 2 plus root 49 times root 2. Separate them. So this is a square number. Find its square root, you get 4 root 2. Then plus, this is a square number, that's 7. Square root of 49 is 7. Then root 2 we won't be able. Then 4 and 7, these ones, now we have same number inside the square root symbol. So you have that. So within that, then you say 4 plus 7 root 2. What do you get? 11 root 2. That's it. Next question is question number 2. I'll also do question number 2, which is a bit, that's rationalizing. Yes. They say rationalize the denominator of. To rationalize the denominator, it means they say rationalize the denominator. This is a question. Rationalize the denominator. To rationalize the denominator of 12 over root 3. This is so simple. That's question number 2. To rationalize this, it means to rationalize the denominator means to get rid of the square root symbol in the denominator. And obviously, if you're doing this, if your surd is in form of algebraic expression, obviously the idea is to find a conjugate, a proper conjugate for this. So for us to be able to do this, what do? We multiply by root 3. So in that case here we have 12 over root 3. Multiply with the same root 3 at the denominator, root 3 on the top, because what we just want to get rid of the square root symbol. And to get rid of the root form, we know root times root is just 1. That's the idea. And that's why we say root 3 times root 3, you get 3. You have root 3 times root 3, you get 3. Root 5 times root 5, you get 5. That's it. So here, your answer will be 12 root 3 over 3. Now you can simplify. Simplify, divide both sides by 3. 3 inside, 4 root 3, divide by 3, 3, 3. Your answer is 4 root 3. That's how you simplify and get the actual answer. Coefficients can be solved like that. So question number 3, it says work out the value of root 12 minus root 3 squared. What do you do in that case? So you say you have root 12 minus root 3 squared. What do you do? So you say here it's root 4 times 3 minus root 3. No. Okay, you can do this one as 8 squared. So what do you do in that case? Simplify first. Root 4, it means 2 root 3. Then minus root 3, because this is square. I've broken that into 2. Then if you've done that, then it's easier. 2 minus 1 root 3. What do you get? You get 1 root 3. Then square it. So 1 root 3 square. 1 root 3 square. It means root 3 times root 3, which is 3. That's what you do. Basically, that's what you're supposed to do to get the answers correct. That's what you're supposed to do. That's an idea that I'm giving you, instead of doing the very complicated way. And let's do another question. Today I will only do 5 questions. Rationalize the denominator of 10 over 5. Rationalize the denominator of 10 over root 5. Rationalize the denominator of 10 over root 5. Give your answer in its simplest form. Rationalize the denominator of 10 over root 5. Give your answer in simplest form. So multiply by root 5 at the denominator and root 5 at the numerator. Wow, that's fine. Root 5 times root 5, you get 5. Then on top, you get 10 root 5. Then you can divide by 5 by 5. 5 here, you get 2. So your answer is 2 root 5. To rationalize is simple. And then the 5th question. Show that root 12 over root 3 plus 2 can be written in the form of a root b, where a is a simplified fraction and b is an integer. Wow. This is fine. Root 12 divided by root 3 plus 2. So what do we basically do in that case? In that case, you can as well add up. So you have root 12 over root 5. 3 plus 2 is 5. Then they want to rationalize. So rationalize it by root 5 by root 5. What do you get? In this case, you get 12 times 5. Because when you multiply, remember that this law, there is a law here. When you say root a times root b, this can be the same as root ab. Don't forget this law. This is a law that we need to know. So the same here, root 12 times root 5, we just say square root that, and then that's square root 60. Yeah, and then from there, we can find, we can now use our idea to find which one is a square. And at the bottom now, at the denominator, you remember, we only have 5. So our answer is root 60 divided by 5. Then how can we go further? So we have 60. Let's try if you can get, let's say 2 here, it's 30. 2 here is 15. Square number, yes, we can get square number. 4. 4 times 15. So 4 times 15. Then do this, break it. This one can be written as root 4 times root 15, which is the same as 2 root 15 over 5. So your answer is 2 root 15 over 5. This is the answer. And you get your answer as that, correct? So now they want, they say keep your answer, write it in the form of a root b. So write in the form of a root b. This is the same as, you say 2 over 5 root 15. This is the form a root b. So that your a is 2 over 5, b is 15. This is a, this is b. 2 over 5 root 15. That's the answer. Wow. That's definitely what is always examined. And let's do a step question. which I can call it the for today's, will end on question number 6. They say these, remember these are the former IGCSE exam style questions in Surds. So if you follow this, you'll be able to pass your examination without any limit. Show that 6 plus 2 root 12 squared is equal to 12 into 7 plus 4 root 3. Wow. Show each stage of your working. So they are saying here, show each stage of your working. So remember this, you have to show each stage, and it's 3 marks. This is where now students don't like it. They don't like math. You have to show all the steps in detail. So what do we do in that case? We just say 6 plus 2 root 12 times 6 plus 2. Bam. That's how you do it. That's how you do it. Expand it. What do you do in that case when you expand? What do we do? 6 times 6, you got 36. 6 times that, what do you get? 6 times that, get plus 12 root 12. Plus this one times that, it is 12 root 12. Then this one times that. So remember here is 2 root 12 times 2 root 12. 2 times 2 is 4. Root 12 times root 12 is 12. So times 12, what do you get? So you get 48. So plus 48. Then that's it. So 36 plus 48. 36 plus 48. 12 plus 12, you get plus 24 root 12. 36 plus 48, it is 84 plus 24 root 12. So this one, you say 24 root 12, it can be as the same as 24 times 4 times 3, which is 24. This will be times 2 root 3, which is 48 root 3. Now our answer generally will be 84 plus 48 root 3. Wow. That's what you do. Now, they said when you do that, remember they say you should show it in the show it as 12 into 7 plus 4 root 3. Now, 84 and 48, what's common? Remember you have 84 plus 48 root 3. The factor here is 12. 12 divide both of them. Sorry, 12 divide both of them. 12 divide 84 7 times. 12 divided by 48 4 times. And this is how you prove. So this is called prove. We are proving by showing what we do. That's what you do, champion. And that marks the end of our lesson today. See you at the top, champion. Bye-bye.